All right, ladies and gentlemen, we're going to look at arcs, semicircles, and central angles. Let's start with an arc. An arc is a part of a circle, all right? And if you make any part of a circle, for instance, let's just put a point K here, and make a small part of a circle, any amount will be fine. You have an arc, okay? And an arc has two endpoints. Let's call these points A and B. All right, and it's the set of all points on that circle between A and B, all right? And the way we name an arc is to name the two endpoints and put an arc symbol above it. Okay, all right, now, the next thing we want to look at is a central angle. A central angle is an angle with its vertex at the center of the circle. It separates the circle into two arcs, all right? So if you have a circle, and I'm just going to put circle K. I love circle K because I'll always choose K if I get a choice, okay? All right, so I'm going to put circle K down, all right? And to get a central angle, you have to have the sides of your angle contain radii. So I'm just going to draw two radii, all right? So I'll draw a radius to this point, and I'll draw a radius over to that point, and I'll call this point J, and I'll call that point L, all right? And now the central angle is angle LKJ, all right? So the name of that, of course, is angle LKJ or JKL, whatever you want to name it. Okay, all right. Now, let's talk about arcs. All right, there are three kinds of arcs. We have minor arcs, major arcs, and semicircles, okay? Any arc whose measure is less than 180 degrees, all right, is what we call a minor arc. Any arc whose angle or whose arc measure is more than 180 but less than 360, it is a major arc, and it has to be named with 3 points. All right, now I'm going to go back up here, and I'm going to name the three different arcs that we have up here in these first two parts. All right, arc AB is a minor arc because it's less than a semicircle. And one thing you need to know is this. If the central angle is x degrees, the measure of the arc out here is x degrees. That's something you need to know. All right, if the arc out here is x degrees, then the central angle that intercepts that arc is x degrees. All right, and if we have a minor arc, here, I'm just going to sketch a minor arc. There's a minor arc AB up here. Arc JL is a minor arc. You can name a minor arc with any 2 points, or actually the two endpoints. You have to name it with the two endpoints. So if I put point K here, and I put a small arc over here to the right, anything less than a semicircle, okay, we'll create what's called a minor arc. There's a minor arc. Let's call this point X, and let's call that other endpoint there Y. And arc XY, you put the two endpoints, and you put a little arc symbol above them, okay? All right. Now, if I want to do a major arc, all right, so let's say I start here with point K, and I'm going to come off to the left as far as I can. And if I go all the way over to there, that would be a semicircle. I need to go more than that. Any amount more than that would be fine. All right. And I'm going to call this endpoint right here point F. I'm going to call that endpoint point D. And I need some other point on there because otherwise I might think you're naming the arc from F over to D. So I'm going to put E right here. And when I name this major arc, because that's more than 180 degrees, I start with one endpoint, so F. I go to the point out on the arc, E, and then I go to the other endpoint, D. So that arc is arc FED or arc DEF. It would be the same either way. All right, now, in a minute, we're going to do the semicircle, so I'll come back to that in a minute. We'll do the semicircle in a minute. Example 1 says, name the following, the central angle. Well, that's the angle formed by the radii, which is angle LEY, LEY, or angle YEL. Name the minor arc. Okay, the minor arc is from L over to Y, so arc LY or arc YL, either way you want to name it. the major arc. That's the opposing arc. By the way, when I say the opposing arc, every minor arc, this one right here, okay, that's that minor arc, has an opposing major arc, okay? They have the same endpoints, all right? So this is going to be our major arc. And the way we name it is we put one of the endpoints, let's start with L, the point out on the arc, which in this case has to be U, and then the other endpoint, Y. Oh my, you can't see that. I'm so sorry. I apologize. All right, so to name this major arc, we talk about arc L, which is an endpoint, then the point out on the arc, and then the other endpoint, which is Y. And then you put an arc symbol above it. Oops, it needs to look more like an arc. All right, adjacent arcs. Adjacent arcs, and I'm going to write that definition off to the right of here. Adjacent arcs are arcs with only endpoints in common. Okay, and those two arcs, that major arc and that minor arc, are what we call adjacent arcs. Okay, let's see what else we know here. All right, now I don't see what's called the arc addition postulate, so I'm going to talk about that right now. I think that's important. All right, so let's talk about the arc addition postulate. We'll start with a circle. We'll call it circle K. And I'm going to use my compass because I can't draw circles very well without my compass. Okay? Now, if I put 3 points anywhere on that circle, let's put point A here, point B right here, and point C right there. That's just at random. All right? I get 4 arcs. Well, there's a lot of arcs there. I'll tell you that. There's a lot of arcs, but I have 3 arcs that I can name. I could name arc AB. I can name arc BC, and I can name arc, well, actually there's more. I can name arc AC. There's 3 minor arcs I can name there, okay? Now, I could name arc BCA. I could name arc BAC. Those are also adjacent arcs, but I would just say, or what I want to do is demonstrate what's called the arc addition postulate, and you can use any 2 adjacent arcs, okay? All right, I'm going to use these arcs. So if I use the arc addition postulate, the measure of arc AB plus the measure of arc BC, because they have only point B, that endpoint in common between those 2 arcs, okay? That would be equal to the measure of arc AC. And that's kind of like the angle addition postulate, okay? All right, and that's what we use for that as well. Now, if you have X number of arcs on a circle that complete the full circle, those arc measures would all add up to 360 degrees. Okay, all right, let's move on in our notes to the next page. And that's what this says, right? The sum of the measures of the central angles of a circle with no interior point in common is 360. And that goes along with the fact that if you have X number of non-overlapping adjacent arcs on a circle, then they would add up to 360. All right, arcs are measured by their corresponding central angles. That's what I was telling you. The central angle is equal to the arc measured. All right, so let's go to example number 2 here. It wants us to find the measure of angle PCM. Well, they told us that was 110 degrees. All right. And then it wants us to find the measure of arc PM. Well, that's this arc from P over M. And if that's 110, then arc PM is 110. Next, it wants us to find the measure of that major arc. Notice it has 3 letters. That's a major arc. P through N. All right, all the way to M. Well, if this arc over here, and I'm going to highlight what I'm talking about, arc PM, is 110 degrees, its opposing arc is arc PNM. And those two are non-overlapping and they complete the full circle, so they have to add up to 360. So x plus 110 adds up to 360. Subtract 110 from each side, and that means that x is 250 degrees. All right, most of us wouldn't write that down, but you could. All right, the next question says, what kind of arc is arc PM? Well, if it's two letters, it has to be a minor arc, okay? Minor arc, and you can say because it has two letters, or you could say because its measure, the measure of arc PM is between, okay, 0 and 180 degrees. That's what the more mathematical thing would be to say. All right, semicircle, we talked about that. To do a semicircle, I will tell you this. If you want a semicircle, all right, you could, if you just want the semicircle, all right, it's kind of hard to just do a semicircle. You may have to, that's pretty close right there, all right, but what I'm gonna do is I'm gonna put in a diameter, because to get a semicircle, you have to have a diameter. So I'm gonna line up this point on that circle, that center of that circle, and draw a diameter, all right? And now if I have point P here, point Q here, and point R there, I know that the measure of arc PQR is 180 degrees, okay? And by the way, there is this opposing arc over here on the other side of that is also a semicircle. Please be aware of that, okay? And I'm going to call that circle K. All right, let's go down and do example number 3 next. Example number 3 says, in circle E, the measure of angle AEN is 18 degrees. Well, if that's 18 degrees, then arc AN is also 18 degrees. And that's the first thing they wanted us to find. So that's 18 degrees. All right, next it wants us to find the measure of arc JA. So from J to A, the shortest route you can go, because that's a minor arc. Please understand that. Okay, well, I know that segment JN is a diameter, and that means to me that JAN is a semicircle. So if JAN is a semicircle, and I know that the measure of arc JA, oops, that's an arc symbol, plus the measure of arc AN, those are adjacent arcs, is equal to the measure of that semicircle, okay, which is arc JAN, all right, using the arc addition postulate. All right, I know the measure, I'm looking for this measure right here. The measure of arc JA plus 18 has to equal the measure of a semicircle, which is 180 degrees, and then I just subtract 18 degrees from each side, and that gives me the measure of arc JA is equal to 162 degrees. Okay, so that minor arc is arc JN is 162 degrees. All right, now it wants us to find the measure of arc J through A as far as you can go to S. So not through S, but J from J through A all the way over to S. Okay. Now, there's some information that we haven't talked about. And let me add that color there so you can see that coming all the way around over there. Okay? All right. Highlighters really help with some of these figures. They get kind of intense. Okay. All right. The next one. Well, there's 2 ways you could do this. All right. What I would do with this particular problem would be to use the fact that that arc JAS, and arc JS complete a full circle. Those two have to add up to 360 degrees, okay? All right, and I know that the measure of angle JES is 90 degrees, all right? So that's a right angle. That means that arc JS is 90 degrees. And then that means if I were to let Y be the measure of what I'm looking for, arc JAS, then all I need to do is say the measure of arc JAS plus 90 equals the full circle, 360, and then all I have to do is subtract 90, and when I do, I find that the measure of arc JAS is equal to 270 degrees. So 270 degrees, Okay? All right. Now, I'm going to tell you these two theorems. They're in your book if you need to look at them. But I'm just going to tell you that here's what they say. All right? Congruent arcs. In the same circle or in congruent circles, two arcs are congruent if and only if their central angles are congruent. Okay? All right? And we talked about the arc addition postulate already. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Okay? So those are important things that you need to remember. All right. We're going to be done today. We'll pick up some more on the next section. Thank you. Bye.